Hello everyone, this is Rupa Lakshmi, student of Computer Science Department at Sri Venkateshwara College of Engineering. Today, I'll discuss on the topic Phases of Compiler from the subject Automata Theory and Compiler Design. These are the topics discussed in the video. Automata theory and compiler design are important fields in the computer science that are closely related to each other. Automata theory is concerned with the study of abstract machines and how they can be used to recognize and generate languages. It provides a theoretical foundation for compiler design by defining the syntax and semantics of programming languages and by specifying the rules for constructing valid programs. Compiler design, on the other hand, is concerned with practical aspects of implementing compilers that can translate high-level programming languages into machine code or other intermediate forms. This involves a variety of tasks such as lexical analysis, paraphrasing, semantic analysis, code generation, and optimization. Overall, automata theory and compiler design play a crucial role in the computer science by enabling the development of powerful and flexible programming languages that can be used to solve wide range of real-life problems, whether you can interested in software development, artificial intelligence, or any other field that involves computing. These two areas are essential components of your toolkit. Compiler operates in various phases. Each phase transforms the source program from one representation to another. Every phase takes input from its previous stage and feeds its output to the next phase of the compiler. There are six phases in a compiler. Each phases helps in converting the high-level language to the machine code. The six phases of compiler are lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimizer, and code generator. Pictorial representation of phases of compiler. Lexical analysis is the first phase when compiler scans the source code. This process can be left to right, character by character, and group these characters into tokens. Here, the character stream from the source code is grouped into meaningful sequences by identifying the tokens. It makes the entry of the corresponding tokens into the symbol table and passes the tokens to the next phase. The primary function of this phase are identify the lexical units in the source code, classify the lexical units into classes like constants, reserved words, and enter them in different tables. It will ignore commands in the source program. Identify tokens which is not a part of the language. Here, in the given example, x is equals to y plus 10, x and y are denoted as identifiers, is equal symbol is denoted as the assignment operator, additional symbol is denoted as the additional operator, and 10 is denoted as the number. Syntax analysis is all about discovering structure in code. It determines whether or not a text follows the expected format. The main aim of this phase is to make sure that the source code written by the programmer is correct or not. Syntax analysis is based on the rules specified for the programming language by constructing the phase tree with the help of tokens. It also determines the structure of the source language and grammar or syntax of the language. Here is a list of tasks performed in this phase. Obtains tokens from the lexical analyzer, checks if the expression is syntactically correct or not, report all the syntax errors, construct a hierarchical structure which is known as phase tree. Example: any identifier or a number is an expression. If x is an identifier and y plus 10 is an expression, then x is equals to y plus 10 is a statement. Consider the phase tree for the following example: a plus b the whole multiplied c. In the phase tree, interior node records with an operation, field, and two files for the children. The leaf node records with two or more fields one for the token and other for the information about the token, ensures the components of the program fit together meaningfully, gathers the type of information and checks for the compatibility, checks operands and permit by the source languages. Semantic analysis checks the semantic consistency of the code. It uses the syntax tree of the previous phase along with symbol table to verify the given source code is semantically consistent. It also checks whether the code is conveying an appropriate meaning. Semantic analyzer will check for the type mismatches, incompatible operands, a function called with improper arguments, an undeclared variable, etc. Functions of the semantic analysis phases are helps you to store the type of information gathered and save it to the symbol table or syntax tree, allows you to perform type checking in the case of type mismatch, where there are no exact type of correction rules which satisfy the desired operation, a semantic error is shown. Collects type of information and checks for the type compatibility, checks if the source language permits the operands or not. For example, float x is equals to 20.2 and float y is equals to x plus 30. In the above code, the semantic analyzer will typecast the integer 30 to float 30.0 before the multiplication. Once the semantic analysis phase is over, the compiler generates the intermediate code for the targeted machine. It represents a program for some abstract machine. Intermediate code is between the high level and the machine level language. The intermediate code needs to be generated in such a manner that it makes easy to translate it into the targeted machine code. Functions of the intermediate code generation are: it should be generated from the semantic representation of the source program, holds the values computed during the process of translation, helps you to translate the intermediate code into the target language, allow you to maintain descending ordering of the source language. It helps to correct the number of operands of the instruction. For the given example, total is equals to count plus rate multiplied by 5. Intermediate code with the help of address code method is generated as shown below. The next phase is the code optimization. This phase removes unnecessary code line and arranges the sequence of statements to speed up the execution of the program without wasting the resource. The main goal of this phase is to improve on the intermediate code to generate a code that runs faster and occupies less space. The primary function of this phase are: it helps you to establish a trade-off between the execution and compilation speed, improves the running time of the target program, generates a streamlined code still in the intermediate representation, removing unreachable code and getting rid of the unused variables, removing statements which are not altered from the loop. For example, consider the following code where the code is written in 4 lines can be optimized and written in 2 lines. Code generation is the last and final phase of the compiler. It gets input from the code optimization phase and produces the page code or the object code as the result. The objective of this phase is to allocate storage and generate reallocatable machine code. It also allocates memory locations for the variables. The instructions in the intermediate code are converted into machine instruction. This phase converts the optimized or intermediate code into the target language. The target language is the machine code. Therefore, all the memory locations and the register are selected and allocated during this phase. The code generated by this phase is executed to take inputs and generate expect outputs. For example, A is equals to B plus 60 would be possibly translated to the registers as shown below. A symbol table contains a record for each identifier with fields for the attributes of the identifier. This component makes it easier for the compiler to search the identifier record and retrieve it quickly. The symbol table also helps you for the scope management. The symbol table and the error handler interact with all the phases, and the symbol table gets updated correspondingly. A symbol table is an essential component of any compiler or interpreter. It serves as the data structure that stores information about the identifiers used in the code. As the compiler or the interpreter reads the source code, it adds entries to the symbol table for each identifier it encounters. Each entry in the symbol table contains various attributes of the identifier, such as its name, data type, and scope. The symbol table makes it easier for the compiler to search for identifiers and retrieve their attributes quickly. This helps to improve the efficiency of the compilation process and reduce the time required to generate executable code. In the compiler design, process error may occur in all the below given phases. Most common errors are invalid character sequence in scanning, invalid token sequence in type, scope error, and phrasing in semantic analysis. This error may be encountered in any of the phases. After finding the errors, the phases needs to deal with the errors to continue with the compilation process. These errors need to be reported to the error handler, which handles the error to perform the compilation process. Generally, the errors are reported in the form of messages. Compiler operates in various phases. Each phase transforms the source program from one representation to another. The six phases of the compiler are lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimizer, and the code generator. Lexical analysis is the first phase when the compiler scans the source code. Syntax analysis is all about discovering the structure of the text. Semantic analysis checks the semantic consistency of the code. Once the semantic analysis phase is over, the compiler generates intermediate code for the target machine. Code optimization phase removes the unnecessary code line and arranges the sequence of the statements. Code generator phase gets inputs from the code optimization phase and produces the page code or object code as the result. A simple table consists of the record for each identifier with fields for attributes of the identifier. Error handling routine handles error and reports done during the many phases. Thank you.